All right, 8.4, properties of rhombuses, rectangles, and squares. Okay, first of all, I want to point out that all three of these are parallelograms. These are different types of parallelograms. Okay, now, in addition to having two pairs of opposite parallel sides, plus all the other info we've already learned about parallelograms, there's a couple things that are special about these three types of parallelogram. All right. A rhombus is a parallelogram with four congruent sides. Kind of like this. It's kind of like, imagine a square that's slanted. Excuse me, sorry. A rectangle is a parallelogram with four right angles, as shown. A square is a rhombus and a rectangle put together. It's a parallelogram with four congruent sides and four right angles, like this. All right? Okay, so these corollaries, a quadrilateral is a rhombus if and only if it has four congruent sides. All right? A quadrilateral is a rectangle if and only if it has four right angles. A quadrilateral is a square if and only if it is a rhombus and a rectangle. Okay.
And you put some in the grass.
All right. Let's go on to page 2. Okay. For any rhombus, RSTV, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. Okay. In a rhombus, I'm going to draw the rhombus over here. RSTV, four congruent sides. Is S always congruent to V? By definition, a rhombus is a parallelogram with four congruent sides. By theorem 8.4, opposite angles of a parallelogram are congruent. So, because these are opposite angles, they always have to be congruent. The statement is always true. Alright, T congruent to V. This is what we're trying to figure out now. If rhombus RSTV is a square, then all four angles are congruent right angles. So, angle T is congruent to angle V if RSTV is a square. But because not all rhombuses are also squares, the statement is sometimes true. Now remember, a square is a type of rhombus, but not all rhombuses have to be squares. Sometimes they look like this. If you have a rhombus that looks like this, all the angles are equal, then this would be true. But that's not always the case, only sometimes. Alright, let's take a look at example 2. Classify the special quadrilateral. Explain your reasoning. The quadrilateral has four congruent sides. One of the angles is not a right angle. So the rhombus is not also a square. By the rhombus corollary, the quadrilateral is a rhombus, because it has four congruent sides, but it does not have four right angles. Alright, I'll let you guys do the checkpoint. Let's go on to page 3. Okay, a parallelogram is a rhombus if and only if its diagonals are perpendicular. So, if you have perpendicular diagonals, you know it's a rhombus. So in this case, AC perpendicular to BD. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Remember, bisects means that it cuts it in half. So, this parallelogram is a rhombus if and only if AC bisects angle A and angle C, and BD bisects angle B and angle D. Okay. A parallelogram is a rectangle if and only if the diagonals are congruent. So if AC is congruent to BD, it's a rectangle. All right, for example, sketch rhombus, where we know it's a rhombus, FGHJ. List everything you know about it. Okay, by definition, you need to draw a figure with the following properties. The figure is a parallelogram, and the figure has 4 congruent sides. Because this is a parallelogram, it has these properties. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. Also, by theorem 8.11, the diagonals of FGHJ are perpendicular. By theorem 8.12, each diagonal bisects a pair of opposite angles. Alright, so let's label all this stuff. So they say that all the sides are congruent. We also know that the opposite sides are parallel. Okay, opposite angles are congruent. Okay. The consecutive angles are supplementary. We don't really have to draw anything for that. The diagonals bisect each other. Let's see if I can draw a straight line. Here we go. Close enough. These bisect each other. And I'm just going to draw this in. This is one of the last things. This makes a right angle. There we go. Close enough. Okay. Let's see here. They're perpendicular. Oh, they bisect each pair of opposite angles. I'm just going to leave it as is. You could separate each of the arcs, but these angles are bisected, as are these. Okay? Alright, let's go on to page 4. You are building a frame for a painting. The measurements of the frame are shown at the right. The frame must be a rectangle. Given the measurements in the diagram, can you assume that it is? Alright, let's do that part. We see that the opposite sides are congruent. Does it have to be a rectangle? No, it doesn't. The boards on opposite sides are the same length, so they form a parallelogram. But you don't know whether the angles are right angles. Even though this looks like a rectangle, you could slant it. Like if you were to slide the top over this way, or slide the bottom over this way and slant it, the sides would still be congruent. Okay, so unless you know that these are right angles, you cannot assume that it's a rectangle. You measure the diagonals of the frame. The diagonals are about 25.6 inches. What can you conclude about the shape of the frame? Okay, now that we know that the diagonals are congruent, by theorem 8.13, the diagonals of a rectangle are congruent. The diagonals of the frame are also congruent, so now we can say that the frame forms a rectangle. Before we could not, without that piece of information. Alright, so I'll let you guys do the checkpoint, and that's all.